Today, we'll be talking about self-sufficient biocatalysis using co-immobilization. The goal of an enzyme is to speed up a chemical reaction. Some enzymes require cofactors in order to function properly. A cofactor is a non-protein molecule that will bind to an enzyme to introduce a new active site. This new active site will allow the substrate to bind to the enzyme. There are some issues, however, with using enzymes and cofactors on an industrial scale. When they are bonded together, like shown, introducing a new active site, these cofactors can be washed away in the presence of an aqueous media. During a batch cycle, if an aqueous media is required for the reaction, the cofactor and enzyme will be separated. This is expensive, requiring constant replenishment of the cofactor in order for the reaction to proceed. The solution? Introduce a porous media with a cationic charge. The negatively charged phosphorylated cofactors will bind to the positively charged porous surface. No longer will the cofactors wash away in the aqueous media. The cofactors will instead exist in equilibrium between the porous media and the aqueous media. This allows the cofactors to be bound to the porous surface while still being available to interact with surface enzymes bound to the porous surface.
To get the substrate to the final product, the use of a production enzyme along with a cofactor is needed. The NADPH is the cofactor for the production enzyme, and that allows the substrate to go into the final product. However, when using NADPH in this scenario, it is converted to NADP+. Therefore, the NADPH needs to be brought back through the use of a recycling enzyme. So the NADP+, after the process, goes through a recycling enzyme to output NADPH. This NADPH can then be used for another reaction with the production enzyme.
Wrapping everything together, the main enzyme is immobilized onto the cationic bed. Then a polymer PEI is cross-linked to those surface polymers. The recycling enzyme is then able to be cross-linked onto the PEI, holding the surface enzymes and the recycling enzymes together. The cofactor is then able to be absorbed into the cationic bed, existing in equilibrium between the bed and the aqueous media. Bringing it all together, this method allows these cofactor-dependent reactions to be used on an industrial scale cheaper and more efficiently.